Here we are given a total cost function for the year for a company that makes executive desks. X represents the number of units or the number of desks, and the output will tell us the number of dollars per year spent on making those desks. We're asked to find the average cost function, so C bar. So C bar of X, so our average cost function, will be the total cost function divided by X. So it's going to be 93X plus 200,000. And we're going to divide that by X. For the marginal cost function, we are going to rewrite the average cost function. So I'm going to take my average cost function, we're going to rewrite it before we find the derivative. This will make it just a little bit easier. So I'm going to take the X and I'm going to divide it into each term from above. So I'm going to divide each of those terms by X. 93X divided by X would be 93. And then 200,000 divided by X, nothing reduces. I'm going to go ahead and move the X up to the top. And of course that's going to change the sign of the exponent to be -1. Now I'm going to actually go and take the derivative. So C bar, we're going to take the derivative of that to find the marginal average cost function. We're going to use the power rule. The derivative of 93 is 0. For the second term, we're going to use the power rule. -1 multiplied times 200,000 is -200,000 times X, and we're going to reduce the power by 1. I'm just going to rewrite this to have only positive exponents. So there's our -200,000, and I'm going to bring that X squared back down to the bottom. And this is our marginal average cost function, which we can see from the equation that this will always be decreasing, which is what we know about our average cost function. As X increases, or as the number of units increases, then the average cost function should be decreasing. We want to know what happens when X is very large. So we take our average cost function, we're going to find the limit as X approaches infinity. So as X grows very large, what's happening to the average cost function? I'm going to take the reduced form again. So let's say that we divide by X. So that would be 93 plus 200,000 divided by X. We're going to find the limit of this. So we're finding the limit of this function. As X goes to infinity, the first term here will not change. That's just a constant, so the limit as X approaches infinity of the first term, 93, would just be 93. For the next term, the limit as X approaches infinity, this is that theorem that we talked about in section 2.6. In section 2.6, we said that if we have a constant on the top of a fraction and we divide it by a variable, and that variable grows to infinity or grows infinitely large without bound, then this fraction would go ultimately to 0. So 93 plus 0, 93. So what this is saying is that as X grows without bound, then the average cost of each desk approaches $93.